Before we get into the details of how the Sagitta CometX MT laser cleaving system can benefit your cable assembly production line, let's take a look at the cleaving process itself and what are the important considerations when cleaving optical connectors. After curing, there is fiber protruding from the end of the ferrule. Looking at a magnified view of the ferrule, we can see the state of the connector after curing. We see the ferrule, the cured epoxy bead, and the fiber stinger, which refers to the excess fiber extending out the tip of the ferrule. The objective of cleaving is to prepare the ferrule for polishing by removing the fiber stinger. This must be done safely, while minimizing the risk of fracturing the fiber underneath the surface of the ferrule. Also, it should result in uniform cleave heights from ferrule to ferrule. The traditional manual method for cleaving involves the use of a scribe to scratch the side of the glass fiber at the top of the epoxy bead, and then carefully breaking the fiber away with your fingers. This requires operator skill and increases operator contact with those dangerous fiber stingers. Manual cleaving, while effective at removing the fiber stinger, often results in a jagged and sharp-edged fiber tip. This sharp tip must be managed prior to polishing to prevent shattered fibers beneath the surface of the ferrule or torn film. Manual cleaving typically requires the additional step of air polishing to knock down the sharp tip. Due to varying epoxy bead sizes, manual cleaving results in an inconsistent cleaved height. This makes the epoxy removal step during polishing more difficult to manage. That same connector is now cleaved using a laser cleaver. The laser cuts through the epoxy bead and fiber, resulting in a consistent cleave height. This ferrule is ready for polishing without any additional processing. Notice how much closer to the ferrule end face we can get with laser cleaving versus manual cleaving. A smooth, clean cleave with no jagged fiber tip protruding means the ferrule is ready for polishing. As we observe from above, you can clearly see the cleanly cleaved fiber in the center. The messy surface of the burned epoxy is normal and will be removed during polishing. The CometX MT requires compressed air. The tubing connectors are located in the rear of the machine. The Venturi vacuum generator uses airflow to create suction. With no moving parts, this is a reliable and maintenance-free way to create vacuum flow. During a cleave, the compressed air exits the output connector and flows into the Venturi vacuum generator and then exits through a silencer. This creates a vacuum, pulling the air from the black tube. The vacuum tube runs through a charcoal filter, which removes the harmful fumes resulting from the laser burning through the epoxy bead during cleave. The filter is easily accessible for periodic replacement. The vacuum line runs to the fiber collection tray and creates downward pressure at the cleave area. As fibers are cleaved, the vacuum pulls the fiber shards into the tray and extracts any fumes from the burned epoxy. The vacuum system sucks cleaved fibers into a disposal tray and epoxy fumes through a charcoal filtration system. Mechanical interlocks within the system prevent accidental laser firing, for example when changing adapters or removing the cover for routine maintenance. Additional safety features monitor the temperature and the vacuum level of the fume extraction system. The Sagitta software allows for simple yet flexible control of cleave parameters, allowing you to optimize settings to get the best cleave for your particular application. Whether you're cleaving typical 125 micron fibers or larger diameter specialty fibers up to 600 micron diameter, multi-fiber such as MTs, or single fiber ferrules, large epoxy beads, small epoxy beads, the Sagitta CometX MT meets your unique needs. When first booted up, the operator will see the Ready page, which shows that the cleaver has passed startup diagnostics and is ready to cleave using, in this case, stored recipe number 3. The next page down is the Recipe Select page, where the operator can select from up to 20 customizable cleave recipes. The cleave recipes consist of up to 3 steps of 3 adjustable parameters: the number of repetitions, the speed of each repetition, and the laser power. This allows you to create and store custom recipes for specific applications. For example, MT ferrules have significantly larger epoxy bead sizes than single fiber ferrules, and thus require a cleave recipe that includes higher laser power and a higher number of repetitions. All recipes are password protected to prevent unintentional changes to cleaving parameters. Additional software controls allow for changes and detailed diagnostics of system components. Sagitta's simple adapter design allows for easy, quick changes between connector types. Simply raise the column, align the locating pins with the holes in the adapter, and tighten the cam lock. A wide variety of adapters are always available and in stock. Custom adapters are available upon request for meeting any cleaving application needs. Once configured, the cleaving process is simple. Simply insert the connector to be cleaved and position the ferrule in alignment with the markers on the monitor. The ferrule position can be adjusted manually to accommodate slight variations in ferrule length. And once the ferrule is properly aligned, depressing the foot pedal will initiate the cleave sequence. The laser will fire and scan across the cleave region at the power, speed, and number of repetitions as defined in the selected recipe. This results in a smooth, clean cleave at a consistent height above the ferrule surface. This is particularly helpful in MT cleaving, where the large epoxy bead size is difficult to control. Here to provide details about the Fiber Optic Center's Silver Plan are the technical team members that would visit your facility to help you make the best cable assemblies in the world.
With decades of actual on-floor experience, we understand and support the entire fiber optic cable assembly manufacturing process. And with an ingrained problem-solving mentality, we're ready to tackle any issue should one arise.
And with this experience, you can have confidence in the equipment and materials we supply. We only work with the proven highest quality manufacturers.
Never mind how other distributors might try to support you. In most cases, we know how the equipment operates and fits into the production process better than even the manufacturer.
With our level of service and the fastest deliveries in the industry, you will get up and running quickly and efficiently, saving you time, money, and headaches.
We know your customers are depending on you, and we can make sure you meet their requirements by quickly getting you going with industry best practices and processes.
If ever a piece of equipment we've supplied goes down, you can rely on our FOC loaner program to make sure disruptions are kept to a minimum.
And in the end, if you are not completely satisfied, the FOC guarantee means you can return the equipment to us with minimal or no cost to you.
Once this piece of equipment is up and running, or maybe even before, we can review your overall production to see where other improvements in manufacturing efficiency and quality can be made, or if cost reductions can be found.
Our long-term intimate relationships with the industry best suppliers mean that we are the first to know of innovations.
And since we aren't beholden to any one supplier or technology, as these innovations become available, you can trust us to vet and get them to you quickly.
And when you purchase from Fiber Optic Center, you get access to our knowledgeable and personable technical team. They can help you out before, during, or even after the installation to make sure everything is working as it should. And if you're not completely happy in the end, we'll take it back. That's the Fiber Optic Center guarantee.
Our number one priority is you.